In the previous video, we had spoken about the pH scale. In this one, we are going to be talking about the ionization of weak acids. Okay, so acids are, before we talk specifically about weak acids, we are going to be talking about acids as such. So the strength of acids, based on the strength, it's classified as weak and strong. Okay, so this strength is dependent on how well it dissociates. So what does that word mean? So when I say dissociates, let's assume you have an acid HA. Okay, so this particular acid will be considered strong if all of the acid splits or separates into H plus and A minus ions. Okay, if it completely dissociates, it'll be a strong acid, or it is going to be considered a strong acid. So this will be strong. But if you have the same thing, okay, but it does not dissociate completely, it'll be a weak. So if it does not dissociate completely, it'll be a weak acid. So that's the difference between a strong and a weak acid. In case of strong acids, it completely dissociates, whereas in case of weak acids, it does not dissociate. Okay, so this in turn implies that the strength of the acid depends upon its dissociation or the ionization constant. So let's think about the a random acid. Okay, so let's say, for example, you have HCl. Now, HCl in water will completely dissociate to give us H plus plus Cl minus ions. Okay, so let's say in the beginning you had HCl of a concentration of 0.1 molar. Okay, so initial concentration is going to be this, right? And the final concentration of HCl, or the final concentration after it attains equilibrium, will be 0.1 molar concentration for hydrogen ions and 0.1 molar for the Cl minus ions. Essentially, what I'm trying to say is the concentration of H plus ions will be equal to that of the concentration of the acid itself. It's completely dissociating to give us the hydrogen ions. Okay, but this is only for strong acids. Other examples of strong acids include nitric acid, hypochloric acid, um, sulfuric acid, hydrochloric acid, right? So let's take an example. Let's take the same example of HA. Okay, now when you have HA, it's a strong acid. We are assuming it's a strong acid, undergoes complete dissociation to form H plus plus A minus, right? Now let's write the equilibrium constant equation. So K will be equal to concentration of H. Oh, I'm sorry. I should have also mentioned that this is in water, right? So HCl, oh, oopsie, HA plus H2O. Okay, so gives rise to H3O plus plus A minus. I meant to take this reaction. Um, so the value of K will be equal to concentration of H3O plus into concentration of A minus whole divided by concentration of HA into concentration of H2O. Right, this is the equilibrium equation. Now, water is in a large quantity, right? So, water is in a large quantity. Also, what we are going to be taking is K into the concentration of H2O is going to be considered to be something called a Ka. Okay, what are we doing? We're taking the concentration of water, pushing it here. It's large enough, so we're just going to multiply it with the concentration of water, and so that's giving us this value called Ka. So Ka will be equal to concentration of H3O plus into the concentration of A minus whole divided by the concentration of Ha. Okay, all I just did was kick this to this side and then K into the H2O was Ka, so we have Ka. Now, this is the Ka is called the dissociation or the ionization constant. What is it called? Dissociation or ionization constant. So Ka is the dissociation or ionization constant. Now the value of Ka, if you notice, directly depends upon the value of the hydrogen ion. So when you have a high concentration of H3O plus, it will imply that the Ka is high. So this in turn implies when you have a high value of Ka, it's a strong acid. Okay, so this is the equation for the dissociation constant. We're just going to ignore the water because that's getting considered with the fact that we're using the dissociation constant itself. Now I've spoken only exclusively about strong acids, right? So in strong acids, you can almost assume that the concentration of Ha will be equal to the concentration of A minus, or I'm sorry, the concentration of Ha will almost become close to, it'll completely dissociate, so it'll be almost close to null. And so because of that, you will have only the concentration of this and this. And so obviously you have the H3O plus, it'll have a high value. However, when you have weak acids, we are also going to be considering another thing called the degree of ionization. So the degree of ionization is given or shown represented by the value alpha. So it is equal to the number of molecules of electrolytes that ionize. Okay, so the number of molecules of the electrolyte that underwent ionization, this divided by the number of molecules of the electrolyte that did not ionize. Okay, so this alpha is basically the degree of ionization or dissociation. So let's take an example of a weak acid. So Ha plus H2O is in equilibrium with H3O plus A minus. So the initial concentration is going to be C for the Ha, and then the concentration of H3O plus and A minus is going to be equal to 0 and 0 respectively. Now the change in concentration is going to be given as, here it will decrease by C alpha. Okay, that is the change. It decreased by concentration into the dissociation, um, or degree of dissociation, and this was, there is an increase by C alpha. Similarly, this is also increased by C alpha. Okay, so what we're doing is we are using the dissociation constant to write, to talk about the change in um, change in the concentration that occurs to achieve equilibrium. Now at equilibrium, the concentration will be C minus C alpha because that's the change, right? And then this will be C alpha, and this will also be C alpha. Okay, so this I can also write it as C into 1 minus alpha. Okay, so what are we doing? Initial concentration is Ha is C, the remaining is 0, and then the change is minus C alpha, concentration minus into the dissociation constant, or I'm sorry, a degree of ionization, and then this is plus C alpha, this is also plus C alpha, and then at equilibrium it is going to be C minus C alpha. 0 plus C alpha is C alpha. Similarly for this one, it's C alpha. So Ka, the value of Ka will have been equal to concentration of H3O plus into concentration of A minus divided by concentration of Ha, right? So let's write down that equilibrium concentration. So it'll be C alpha into C alpha divided by C into 1 minus alpha. Cancel 1C for both of them, numerator and denominator. So you're left with C alpha square by 1 minus alpha. Okay, so this is the using this, we actually are able to calculate the pH. Okay, and I'll get to that in a second. So this till here we've learned two very new terms. One is Ka, which is the dissociation constant or ionization constant, and alpha, which is the degree of dissociation. Now, the pH scale is so useful, right? So what we do is we have another value called pKa. So pKa is equal to minus log Ka. pKa is equal to minus log Ka. So when you have a strong acid, okay, strong acid, the value of Ka will be high. So high value for Ka, and the value for pKa will be low. For a weak acid, on the other hand, you have a high value, sorry, a low value for Ka and a high value for pKa. So using the value of Ka and pKa, we are actually able to figure out the strength of the acid. Okay, so because you have a higher concentration of H3O plus, a stronger acid would have a higher value of Ka. Okay, whereas in case of a weak acid, because the concentration of H3O plus will be less, it will have a low pKa value or a low Ka value. I am so sorry. So basically, we are using the various values of um, Ka, which is the dissociation or ionization constant, and the concentration, we are able to actually calculate the degree of ionization, which is the value of alpha, as well as the pH of the solution. So for us to do that, there is a step-by-step thing given in your textbook. What we are going to do in the next video is we are going to solve the question given. That is, I'm pretty sure it's 6.1, no, 6.16, no, 6.18, and what we're going to do is we're going to solve that step by step alongside the various steps given in that textbook. I know it's going to be a long video, but it'll be worth it. Okay, so in this video, what we did was we basically learned two new terms, which is the three things: Ka, pKa, as well as alpha. The reason these are important is because it helps us actually calculate the value of the pH. It helps us calculate uh, the degree of ionization, and all of those things for weak acids. I hope all of that made sense, and definitely let me know if you prefer if I use the whiteboard over the laptop or vice versa. So